Welcome to our robotics activity compilation. In this video, we will be showing different projects we have worked on throughout our robotics course. Each activity helps us understand how motors, sensors, and coding work together to bring our ideas to life. Our compilation includes activities using the serial monitor, ultrasonic sensor, IR sensor with DC motor and MOSFET, and DC motor with H-bridge. Through these experiments, we learned how to measure distance, detect obstacles, control lights and motors, and even use Arduino to communicate and respond to commands. This journey has been full of discoveries, challenges, and teamwork, but most of all, it taught us how creative and powerful robotics can be when we apply what we have learned. Now, let's take a look at our activities. For our first activity, titled Printing Text in the Serial Monitor, we use only one component, the Arduino Uno. In this setup, the Arduino sends the message, "Hello student," to the serial monitor every second. The message keeps appearing repeatedly, showing how the Arduino continuously communicates with the computer. For our second activity, showing temperature readings, we use an Arduino Uno and temperature sensor. The sensor detects the surrounding temperature and sends the data to the serial monitor in degrees Celsius. This activity shows how we can monitor temperature changes in real time using simple electronic components. In our third activity, checking if the button is pressed, we use an Arduino Uno and a push button. When the button is pressed, the serial monitor displays the message, "Button pressed." This helps us understand how Arduino can detect and respond to user input through a simple button press. For the fourth activity, serial monitor as remote control, we use an Arduino Uno, an LED, and a resistor. In this setup, we can turn the LED on or off by typing commands in the serial monitor. When we type 1, the LED lights up, and when we type 0, it turns up. This activity shows how we can control electronic components using simple type inputs. And finally, for our fifth activity in the serial monitor, which is light sensor logging, we use an Arduino Uno, a photoresistor, and a resistor. This setup measures the brightness of the surroundings. The light sensor detects how bright or dark the area is, and the readings are displayed on the serial monitor. When it is bright, the readings are higher, and when it is dark, they become lower. This activity demonstrates how Arduino can be used to record and observe changes in light.
Activity 1. Distance Measurement Display, version 1. In this activity, we use the ultrasonic sensor to measure how far an object is from the sensor. The distance is shown in centimeters on the serial monitor. The ultrasonic sensor works by sending out sound waves and measuring how long it takes for the echo to return. This shows how sound waves can measure distance, the same idea used in sonar and parking sensors. Activity 2. Distance Measurement Display, version 2. For this activity, we again used the ultrasonic sensor, but the result was displayed on LCD. The LCD allows us to show readings directly on a small screen, making it easier to view results in real time without a computer. This setup is useful for projects like digital rulers and smart measuring tools. Activity 3. Obstacle Detector. In this activity, the ultrasonic sensor detected if an object was within 10 centimeters. When it was too close, an LED turned on as a warning. The LED lights up when electricity passes through it, making it perfect for visual signals. This shows how sensors and simple indicators can be used in proximity alerts and collision avoidance systems.
The IR sensor detects surfaces based on how they reflect or absorb infrared light. A white surface reflects more light, sending a high signal, while a black surface absorbs light, sending a low signal. The serial monitor then displays whether a light or dark surface is detected. This activity creates a simple alarm system using an IR sensor, Arduino, buzzer, and LED. When an object is detected, the sensor triggers the buzzer and LED to turn on, serving as an alert. It demonstrates how IR sensor work in motion detection and security application. This activity uses an IR proximity sensor and an Arduino to count objects passing by, displaying the total on an LED screen. Activity 1. Pressing a button activates a MOSFET, running the motor, releasing stops it. This showcases basic digital control and MOSFET switching. Activity 2. A potentiometer controls motor speed via Arduino and a MOSFET, demonstrating analog input and variable speed control.
DC motor with H-bridge. Activity 1 motor power control. In this activity, we'll implement basic on and off control of a DC motor using an Arduino Uno, a battery, and an H-bridge motor driver. The Arduino will directly control the H-bridge, enabling or disabling the flow of current from the battery to the motor. When the Arduino sends a high signal to the H-bridge, the motor spins. When the Arduino sends a low signal, the motor stops. Activity 2 motor speed control. In this activity, we use a potentiometer to control the speed of a DC motor with an Arduino Uno. The potentiometer is connected to an analog input pin on the Arduino. As you turn the potentiometer, the voltage read by the Arduino changes, and we will program the Arduino to monitor this voltage. The Arduino will interpret the voltage level as a speed setting. The Arduino will then send a pulse width modulation signal to the motor driver, which regulates the amount of power delivered to the motor. Activity 3 motor direction control. In this activity, we program a DC motor to run in an alternating cycle using an Arduino Uno, an H-bridge, and a power source. The motor will run in one direction for a specified duration, then pause for 1 second, and then automatically reverse direction for another set duration. Activity 4 push button motor direction control. In this activity, we use 2 buttons to control the direction of the DC motor. Pressing one button makes the motor spin in one direction, while pressing the other button makes it spin in the opposite direction. If neither button is pressed, the motor remains stopped. Activity 5 motor direction and speed control using push buttons and potentiometer. In this activity, we combine directional control using 2 buttons with speed control using a potentiometer for a DC motor. Pressing one button makes the motor spin in one direction, and pressing the other button makes it spin in the opposite direction. The potentiometer allows us to adjust the speed of the motor in either direction.
Throughout our robotics course, we learned how to combine coding, electronics, and sensors to build simple automated systems. Using the serial monitor, we practiced displaying data, controlling devices, and logging sensor readings. With the ultrasonic sensor, we discovered how to measure distance and detect obstacles for a system like parking assistant. Through the IR sensor and DC motor with MOSFET, we learned about motion detection, color sensing, and motor control. Lastly, using H-bridge, we control a motor speed and direction with buttons and potentiometer.
Our robotics journey has been full of challenges and lessons. There were times when we get frustrated trying to fix errors or wiring issues, but every mistake taught us something new. Seeing the process in our performance and activities feels really rewarding because it shows how much we have improved since the beginning. Those moments reminded us that learning doesn't always mean getting things right in the first time. Sometimes it is about staying determined, learning from our mistakes, and growing through every step of the process.
These courses changed our view of technology, robotics, and engineering. Through activities like controlling DC motors, using sensors, and programming Arduinos, we learned how coding, electronics, and design work together to create automation. It helps us see technology not just as machines, but as creative tools for problem solving, innovation, and making everyday tasks easier and more efficient.
We are looking forward to develop wireless modules such as Bluetooth or Wi-Fi and control the motors remotely through our phone application or connect our projects with cloud services. These would bring us up to hardware capabilities in relation to IoT and enable us to venture into field of data transmission in reality. Also, we would like gas sensors, which will identify air quality based on the presence of such gases as smoke and CO2. They may be applied in environmental monitoring, safety systems, or smart ventilation, and the combination of electronics and chemistry is used in the real world.